A more useful measure of how spread out the numbers are is called the standard deviation. And the standard deviation, a small standard deviation means that the numbers tend to be grouped very tightly around the mean. A large standard deviation means they tend to be more spread out. The same can be kind of said for your range, but if you had if you had some data where, let's say, your histogram looks something like this, you know, the vast majority of the numbers are right in the middle, and there's just a few outliers that might make your range look rather large. But actually, this is, you know, the data is by and large very close to the center. The standard deviation kind of takes all this into account, and it has a much better ability to ignore some of those outliers, some of those some things that happen there. Now, the actual way to compute the standard deviation is a little bit more complicated. You can see it involves a square root, 1 over n minus 1. We take a sum of a bunch of things, a bunch of x minus the mean. Remember, this x bar means the mean. And you square those, and you add them all together. If you wanted to compute it this way, it is possible. Here's another formula that some people use. These formulas are equivalent as far as I'm concerned. I don't recommend using them, though, because you have the ability to use calculators. And so I will show you this on the TI-83 since I'm able to pull that up here, and I'll have to post a separate video for showing it on the TI-36X Pro. So what you'll do is you'll go ahead and enter the values into the calculator. So we're going to go into Stat and Edit. So this is, you're going to enter all of your values into L1. So this, I'm just going to use this data here as my example. It's 3, 5, 6, 3, 3. So I'll enter each of the values in here. 3, enter 5, 6, 3, 3. You can see I have those 5 values entered in there. Now I need to quit back out to the home screen because in general when you're running functions you need to run them back in the home screen. I'll go back into Stat, and this time I'm going to go over to Calc. I press the right arrow here to go over to Calc, and we want specifically one var stats. For now, I'll just go ahead and run that. There are some arguments I can put into that, but for now I'm just going to run it. So one of our stats looks like this. We have x bar, remember that's our mean. So our mean, x bar is, what was it, 4? So we don't have to go through the process of adding these up together and then dividing by 5. This is actually showing up in one of our stats. There are some, the sum of all the x's, the sum of all the x squareds. These are used to compute it. These are actually these values used to compute it for this method. It's the SX. This is the standard deviation that we're looking for, this 1.414. Standard deviation. That's SX in this calculator. It's approximately 1.414. This is sometimes referred to as a sample standard deviation as opposed to the population standard deviation. The only difference between a sample standard deviation and a population standard deviation is it's either dividing by n or n minus 1. For the purposes of this class, we're only interested in the sample standard deviation, so that's going to be dividing by n minus 1, not dividing by n. If you take a different stats course, or if you study that more, you'll look at what is the difference between a sample mean and a population mean, and a sample standard deviation and a population standard deviation. Those sorts of things, but we're not going to get into that. We're just using the SX, so you can ignore the sigma x. That's the Greek letter sigma that we're not using. All right. So if you scroll down a little bit more, I just press the up and down arrows to move around in here. You can see there's n, if we wanted that, and there's also the min x and the max x. This is the smallest value and the largest value. You can use those for finding your range, and you can see right here is the median. So there's our median. So in this one var stats, there's all sorts of values that are helpful. The Q1 and Q3 we don't need. Those are quartiles. Those are if we, so just to briefly explain it, you're not going to need it for the purposes of this class, but in case you're curious, this is our mean right here. And if we kind of throw that away and we take the mean of the first 2 points, that's a 3. If we take the mean of the first half, if we take the mean of the median, I'm saying mean. If we throw away the median, we take the median of the first half, this is Q1. This is the first quartile. If we take the median of the second half, this is 5.5, because there's two values, we'd have to add them together and divide by 2. This would be Q3, that's the third quartile. If you ever hear people talking about a box and whisker plot or something along those lines, they're using these values. But again, this is getting into more statistics that we don't need for this class. Alright, so we found the mean, we found the standard deviation. I haven't said what the variance is, though, because the variance is just what we get if we did this formula without the square root. This is something that we don't use too incredibly much anymore, and we're going to find it just by taking Sx and squaring it, taking whatever we got for our standard deviation and squaring it. So let's see, 1.41421, and if I square that, I get, well, 2. I recognize this 1.414 as the square root of 2. It actually is 2 up until, a bunch of decimal places over here, and of course those decimal places, that inaccuracy is because I didn't put in more accuracy for my standard deviation. So oftentimes the variance will actually come out as a nice number, standard deviation will not. The reason the variance exists is more of a historical reason than anything. Variance is a lot easier to compute because if you're doing this, you can do this all on a spreadsheet. You can do you can add numbers together, you can square them, you can even do the division by n-1 relatively easily. But when it comes to square roots are a lot harder to do by hand, and typically you have to consult a table of values to find a square root. I mean, there are methods for finding square roots, but they're just time consuming. And basically this square root command, the square root is a lot harder than all the rest of the other things. It takes longer. And so people ended up starting to deal with the variance because a lot of the things that are true about the standard deviation are also true of the variance. And you're not losing any information if you're talking about the variance. So. But like I said, it's kind of outdated. So we're going to just use the standard deviation because our calculators can do square roots without us having to blink. Alright, so let's talk about why the standard deviation exists. What proportion of the data is within one standard deviation of the mean? When we're talking about these values, if we have a 3, 4, 5, 6, those are our values. I'm putting the 4 in there even though it doesn't occur, just because I'm about to construct a histogram. So 3 occurs 3 times, 4 doesn't occur at all, 5 occurs once, and 6 occurs once. This is what our histogram looks like. We saw that our mean is 4. So the center of balance is right here at 4. 3 happens more frequently, but it's also closer to our mean than these two over here. So, well, it's closer to our mean than 6 at least. And so this would balance right at 4. If I was to put this on a scale or put this on a balance right there, it would be balanced right when we're at 4. The standard deviation says if I was to take one step, this is kind of a step size. If I was to step by that standard deviation size once to the left or once to the right, I would get one standard deviation away from the mean. So let's see, the mean is 4. If I take one step to the left, I would get 4 minus 1.414, I would get 2.586. So I would include all of those 3 values. Okay, if I was to go one standard deviation to the right, I would get 5.414. That would be just over here. Actually, maybe I should be like there and there. 5.414. So if I ask this question, what proportion of the data is within one standard deviation of the mean? Well, let's see. The 3 is, the 3 is, the 3 is, and the 5 is. The 6 is not, though. So we would get 4/5 of the values. 4 out of the 5 values are within one standard deviation of the mean. This would be 80%.